you by thesis123.com. I learn and teach online.
Here's the next question, number 21. For the network shown in the figure below, the frequency in radians per second at which the maximum phase lag occurs is dash. Okay, so here we have been given a circuit, a network, and we have been asked for the frequency in radians per second. So frequency in radians per second is the angular frequency omega. So we need to find out the angular frequency omega, and in order to do that we would first need the ratio of the output to the input in terms of S. So that will help us find out what the angular frequency is. So V naught of S by V in of S is what we need to find out first. Okay, so V naught of S. Alright, now let's look at the output here. So the output here is based on the resistance and the capacitance here. So resistance, it's across this, and we need it in terms of S. So that is R plus 1 by SC. It's R plus 1 by SC. So that is across the output here. Next, we need it in terms of the input. Now the input covers two resistance and capacitance. So here we would have total RT, I'm writing it as RT to indicate the total resistance, plus 1 by SC. Now let's plug in the values. We have R here is just this value over here, 1. So that's 1 plus 1 by SC. C, we have the value of the capacitance as 1 farad. So here we have 1 plus 1 by S divided by, in the denominator here, RT is the total resistance, so that's 9 plus 1, so that's 10. 10 plus 1 by S. Now if we simplify this further, we will have the ratio of V naught by V in terms of S, of course, S plus 1 divided by 10S plus 1. Okay, so omega, the frequency, here is a very basic formula, an important formula. Omega is equal to 1 by T root A. It'll do good to remember this. Omega is equal to 1 by T root A. Now the values of T and A will correspond to the coefficients of S in the ratio of output by input. So here is an important point. The value of T is the coefficient of S in the numerator, and AT is the term corresponding to the coefficient of S in the denominator. So if we are to look at the numerator over here corresponding to the output, okay, so T is the coefficient of S. So we see that the coefficient of S is 1. So from here we get that T is equal to 1, and AT corresponds to the coefficient of S in the denominator. So AT is equal to 10. If AT is equal to 10, then A is equal to 10. That's because T is 1. So A is 10. Now we have A is 10, we have T is equal to 1. Substitute these two values over here to find your omega value. So I'll put that down right here. Omega would be equal to 1 by root 10. So our final answer is omega is equal to 0.316 radians per second. Okay, so here is the value of the frequency in radians per second at maximum phase lag. So that's the point over here. So the formula for omega at maximum phase lag is 1 by T root A. So I hope this generalization has helped.
Thank you for watching this video. For future videos, please click here to subscribe YouTube channel. Visit our site thesis123.com for free student project or research ideas and online training. Follow us Facebook, Twitter, Google+ and Pinterest.